Hi! In this video we present one of the most important technique of calculus of primitives, the rule of calculus by parts. The starting point is the rule of calculus for the derivative of a product. This says that if we have two functions, f and g, which are both differentiable, the derivative of f times g is equal to f prime g plus fg prime. Now this formula says also that f times g is a primitive of the right-hand side. So with the primitive notation we can say that a primitive for f prime g plus fg prime is f times g. And because of the linearity of the primitive of the sum is the sum of the primitives, we have this. Actually this relation can be seen as a rule of calculus for a primitive when the shape of the function is of this type, f prime times g. Precisely, we have that a primitive for a function of form f prime x gx is equal to fx gx, which is an explicit term, minus a new primitive where we have to compute the primitive of fx times g prime x. So the scope of this formula is the following. Suppose that we have to compute a primitive and we recognize that our function in the primitive can be written as the product of two functions of which one of them is a derivative of something. In this case, it is the derivative of some function f. Then, if this is the case, you can say that this primitive is equal to this product, which is explicit, so it does not require any further calculation, minus a new primitive where you can see that the derivative moves from the factor f to the factor g. Of course, the hope is that the new problem that we have to solve will be easier than the initial one. Let's see this on some examples. The first example is the following. We have to compute the primitive of x times log of x. Clearly here we see immediately a product, x times log x. And one of the two factors, namely x, is easily a derivative. It is the derivative of x squared over 2. So we can see this as derivative of x squared over 2 times log x. So this is the fx prime times g of x. Therefore, the formula says that this primitive is equal to the product f times g, so x squared over 2 times g log of x, minus, now the derivative moves from the first factor that remains in the primitive x squared over 2 to the second factor, so we get a derivative of log of x, which is equal to 1 over x, and this simplifies with this x squared, yielding this new primitive to be computed, the primitive of x, which is clearly easier because than initial one, because this is an elementary primitive. It is the primitive of an elementary function, and the answer is this one. By using this idea, we can compute, for example, the primitive of log of x, which is an elementary function for which we have not yet seen a formula for the primitive. Actually, here we don't see a product. So how can we use the calculus by part rule? Well, we can always think that log of x can be seen as 1 times log of x. And that one is a derivative. It is the derivative of x. So we have derivative of x times log of x. We apply the rule of calculus by parts, and we get x log x, minus now the derivative moves from x to the logarithm, and therefore we have x times the derivative of log of x, which is 1 over x, and this simplifies a lot the new primitive because we get just the primitive of 1, and this is exactly x. So we have the result, and in particular we obtained a primitive for the log of x. In a similar way, we can compute a primitive for arctangent or for arcsine, or for the inverse of the hyperbolic sine and many others. I suggest you to try to do these calculations by yourself. In the next example, we have the primitive of x sine x, and here we have a new situation. In fact, we see that clearly this is a product between two functions, and in this case we can see each of the two factors as a derivative. So in the first case, we can see x as derivative of x squared over 2. So we write x sine x as derivative of x squared over 2 times sine x. Or we can see sine x as the derivative of minus cosine x, and therefore we write x sine x as x times minus the derivative of cosine x, or derivative of minus cosine x. Now, which one of these two ways to write this product is better? Let's see what happens if we apply the calculus by parts formula to the first expression. So after the application of the formula, we have x squared over 2 times sine x minus, now derivative moves from the x squared over 2 factor to sine x, and therefore we get x squared over 2 times derivative of sine is cosine. We get this. So the new problem, apart from the factor 1/2 that can be carried outside, is the primitive of x squared cosine x. So we started from primitive of x sine x, and we ended to the primitive of x squared cosine x, which doesn't look much better than the initial one. So let's see what happens if instead we apply the calculus by part rule to the second way to write this product x sine x. We get here minus cosine x times x. Now we move the derivative from minus cos x to x, and we get derivative of x is 1. We get 1 times minus cosine x. So the new problem is just to compute the primitive of cosine x, which is an elementary function, so we have immediately the answer. So the moral is that in this case, the choice of which factor to represent as a derivative is not indifferent, because only one of the two choices leads to a simplification of the problem. In the next example, we have still a product, e2x sine x, of which we want to compute a primitive. And also in this case, we have that both factors can be seen as derivative. But here, as you will see, the choice of which of the two to see as a derivative is actually indifferent. In fact, we can say that e2x sine x is derivative of e2x times sine x, or e2x times the derivative of minus cosine x, because this yields sine x. Now, applying the calculus by parts formula to the first primitive, we get e2x sine x minus the primitive of, now derivative moves from this factor to this one, e2x times cosine x, which sounds a little bit similar to the initial primitive. So we do not get any particular simplification, apparently. If we do the same with the second primitive, so the second way to write the primitive of e2x sine x, we get minus cos x e2x. Now derivative moves from minus cosine to e2x. Derivative of e2x is, of course, e2x. And therefore, the new primitive is this one. That apart from sine that we can carry outside, we have the primitive of e2x cosine x, just the same. So what can we do now? Well, now the trick is that if we continue once more applying calculus by parts to this one, or this one is the same. So take this one, for example, and insist with the e2x. So think this as the derivative of e2x and apply calculus by parts once more. We have that e2x sine x, which was the explicit term we found here, minus, now we have e2x cos x. Derivative moves from exponential to cosine, and we get minus sine. If you look here, the new primitive, this, apart from this minus, well, you can carry outside, it is exactly the initial primitive. So we return it back to the beginning, apparently, but with an important feature here. So let's clean up all this and write only the formula we obtained. Now, working out the algebraic steps here, so we have an explicit part, which is e2x times sine x minus cos x. And then minus, 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 so 3 times minus, it's a minus, the primitive of e2x sine x, which is just the initial one. But now we can look at this as an equation, where this quantity is equal to this minus itself. So we can carry this primitive at left, and this primitive will be multiplied by a factor 2, and this yields this final formula. That's it. Now it's your time to do something, and as usual, I propose you to do some exercise applying the calculus by parts on these problems. Have fun.